Good morning, everybody. Thank you for joining us this morning, and welcome to the Cupron Breakfast Symposium. We're going to get underway now, so it really is my real pleasure to welcome you here today. So, Cupron Medical Textiles is obviously the host, and just a couple of minutes of housekeeping. So on the tables, there are obviously some brochure information. There's also some fabric samples. I would encourage you and welcome you to A, go talk to your fellow attendees, and B, to go fill those fabric samples if you get an opportunity. We will be taking questions at the end, and we'll have a microphone for that. So if you could just hold your questions until we get to the end, that would be terrific, and we'd appreciate that. I have some colleagues in the room, so Chris is at the back. There'll also be a couple of other Cupron folks circulating, so if you need anything, feel free to grab us and just ask us. And so really this morning, what are we going to be talking about? So we're going to be talking about the role of the environment and linens in that infection vector. We're going to be talking about our technology, the Cupron copper antimicrobial technology. We're also going to be explaining why we think copper is A, an excellent antimicrobial, and B, a clinically validated tool to help you in the fight against HAIs. And then it is a real pleasure, we're going to have Sentara Healthcare System and Ochsner Healthcare System tell you a little bit about their clinical data and their experience using our products, and really at a high level telling you a little bit more about how they found working with us and deploying us across their systems. So we'll also then, as I say, at the end have a question and answer session. So with that, it is really a pleasure to introduce Jackie Butler and Dr. Richard Milani. So Jackie is a corporate director of infection control and prevention at Sentara Healthcare System. She's worked in the field for a while, I think it's fair to say. She's been certified as a CBIC since 1991, and since 1985 has been a very active member, I think, of the APIC community and the Virginia APIC community. And it really is a pleasure to have her here with us today. Dr. Milani is the Chief Clinical Transformation Officer and the Vice Chairman of Department of Cardiology at Ochsner Healthcare System, and a Professor of Medicine at the Ochsner Clinical School, the University of Queensland School of Medicine. His interest really is in population health, with a special interest in chronic disease and medical innovation, and also serves as the Medical Director of Innovation Ochsner, which is a healthcare accelerator based in Louisiana also. He's authored over 500 papers and is a frequent lecturer, and so we're delighted that he could be here to add to our portfolio this morning. So with that, we're going to just sort of set the scene, I think. The information I'm going to talk to you about right now, especially some of the environment, you probably all know better than we do in your daily fight. But we're hoping we can, add to some of that knowledge base a little bit by looking at some of what the literature tells us. So why do Cupron and why is the environment so important? And there was a great paper that was published last year. I'm sure all of you saw it, but it quantified the risk for a patient coming into a terminally clean, turned over room where the prior occupant had an infection or the prior occupant's roommate had an infection. And really what this tells us is, despite environmental decolonization, despite cleaning measures, there is still a high risk from the environment for the next patient coming in to acquire that infection. So anywhere from 5 to 6 times more likely to acquire that same infection if the prior occupant, or even if the prior occupant's roommate had that infection. So we thought this was a really great way to kick off today, to talk about what additional measures are there to help you to complement all the other practices and procedures that you're doing, especially for environmental decolonization, reducing that environmental bioburden. And this work really built on a prior paper that came out back in 2014 that quantified the individual risk by organism for acquiring that infection if the prior occupant had it. So 1.5 times more likely to get MRSA, all the way up to 3.5 times more likely to acquire Acinetobacter baumannii. So, C. diff 2.5 times more likely if the prior occupant had that infection. One of the things I'd say right now is, if anybody would like these slide decks or any of the information in the slide today, you have my business card, please contact me. We'd happily make these available to you, some of this information. So one of the things that Cupron did early on is we had a platform copper technology that we did some really interesting work in the consumer division and in the cosmetic industry. But one of the things that we looked at early on was, how do we move into healthcare? And so one of the areas that we looked at and focused on really heavily was, what are the most touched and contaminated surfaces in the healthcare environment for MRSA and C. diff? And how do we potentially add our antimicrobial agent to those areas in order to reduce that level of environmental bioburden and potentially see if we can provide value in that setting? And so this is an infographic that we put together based on the literature searches that we could do at the time. The color codes are obviously the darker the color, the more contaminated or the more touched. And the key thing that we saw was the area surrounding the patient is really the most touched and most contaminated surface, which intuitively makes sense. The patient is the source of a lot of that environmental contamination. You know, they're either super shedders or shedding highly into that environment. The patient area surrounding it is obviously where it's frequently touched, turned over. A lot of the care obviously is provided to the patient in the bed. And so a lot of those areas are the areas that we felt that we could have an impact. So those linens are obviously a great vector for growing microorganisms. They're in close contact with the skin, there's high humidity, there's organic material. So that linen factor surrounding it, the patient gown and bed linens, as you can see, we handily circled them for you so you really couldn't miss it on the infographic. That area was an area that we felt that we could potentially assist by putting our technology into that area. So I think everybody in this room knows that you are getting hygienically clean linens from your healthcare provider. What we wanted to do was put a long-term durable antimicrobial agent into those textiles so that we could assist downstream once that hygienically clean linen gets put into the patient environment and the patient starts shedding onto it and potentially adding to that environmental burden. And so if I had to sort of sum it up in a nutshell, that's really what we wanted to do. We wanted to surround the patient with continuously self-sanitizing textiles to reduce the environmental bioburden and therefore see if we could clinically validate and prove a lowering of HAI rates by reducing that environmental contamination. And so to do that, we took our technology and we put it into a variety of different fabrics and fibers. But what our technology is in a nutshell is taking recycled copper compounds on the top line of this carousel. We specify the type of copper that we'd like to use. We put it into the plastic chip ahead of that being turned into fibers, so it's physically put into the product ahead of manufacture. Those plastic pellets basically get pushed through a shower head. Anybody from the textile industry would probably hate me for saying that, but it basically looks like a shower head. And it pushes through and makes these fibers, and these fibers then can be combined with cotton to make the products that are on the tables ahead of you. And so that then makes all of our fabrics and fibers. It's a long-term, durable copper antimicrobial agent added to the textiles prior to manufacture for durability and also for longevity. And so we've looked at our technology over a period of different times, but one of the biggest things that we've looked at is efficacy. So, you know, a great question comes with, well, as soon as you start washing it, what happens to your efficacy? So we've taken our efficacy studies all the way out to well and over 100 launderings, and just showed two examples here of two of our products that we have put through real-world laundry environments to demonstrate that we have durability at 50 and 100 washings. So both of these products, we put our whole package through, but these are just examples of handing them off, as I say, to real-world launderers, saying, please wash these the way you wash everything else. We'll come down and we'll grab them every 10 and we'll just test them all the way through. And this number is in excess, as you'll see later in the presentation, way in excess of the actual standard life that you would get from a lot of your textile products anyway. But we wanted to have confidence that we could survive well past the durable life of that technology. So why copper? It's a fair question. Why copper? We get this question a lot. You know, it's obviously, as we know, it's continuously active. What does that mean? Well, it survives repeated challenges. It's very effective. It's broad spectrum. It's been used for many, many years in a variety of different industries. Agriculture have used copper as an anti-fungicidal agent for many, many years. We've used it, as I say, successfully in a variety of other industries as well in order to be able to show good antimicrobial efficacy. So broad spectrum, bactericidal, fungicidal, sporicidal activity. We also feel that it's the most practical with the way that we have deployed the copper to be physically put into the product, surviving numerous repeated launderings with not having to add anything or change anything. We think gives it the best sort of practicality, as well as being one of the most efficacious agents that are out there. And you know what's probably of interest to this room, you know, we obviously have had the pleasure of interacting with you across a number of different events, but what we hear obviously is peer-reviewed published studies. You know, this is what the field is looking for, outcomes-based studies. So really copper's had a growing broad base of evidence that has been published over the last sort of 5 to 10 years, and we're delighted to say that we are at the forefront of a lot of those publications, 5 out of of 6 of the peer-reviewed publications that actually show HAI reductions are Cuprons, and we're going to review them today. I'm going to review some of the early work that Cupron's undertaken, and then I have the pleasure of having Jackie take you through the independent trials that Centera has undertaken with our technology. But those trials have all resulted in a statistically significant and consistent 24 to 40% reduction in HAIs. And so how does it work? So for any of the microbiologists in the room, this is probably where everybody starts perking up and getting excited. I am a microbiologist, so this is the point at which I kind of get to enjoy myself. But it works for a broad variety of mechanisms. So obviously the copper that's physically locked into the fibers releases copper ions. Those copper ions can penetrate into cells, and once they're in there, they can shut down metabolism, energy production, reproduction. On top of that, there's also a transmembrane potential which can be disrupted, a physical mode of action, where by stealing electrons out of that cell wall, it disrupts that potential, punching holes in that bag in the outer membrane. And then there's also an oxidizing mechanism that comes into play because of the copper that we choose that can weaken that cell wall. So on a whole variety of levels, there's either physical mechanisms where holes are being punched into these basically bags of fluid, which can cause cell death, or the copper ions themselves can cause cell death, or reactive oxygen species, which can be generated from the dissociation of the copper, can also cause cell death. What does this mean in the longer term? In conjunction with hygienic practices, we don't expect to see resistance to copper. It's been widely used, as I say, in the agriculture industry for a very long period of time, with no evidence of resistance being born yet, and especially in conjunction with hygienically clean linen practices, we don't expect to have anything left over on your linens that could lead to resistance being generated. So from here, I'm just going to quickly pivot and start telling you about some early work that we did. So we obviously had an idea about the most touched and most contaminated surfaces. We knew that we wanted to assist in the healthcare industry. We knew that we had a great platform technology to go into linens and to go into textiles, patient gowns, and all of those products. But what we were lacking, and we knew we had a very good antimicrobial agent that could survive numerous launderings. What we were missing was probably the next step, which is what does it do in the real world? What does it do in the clinic? So we undertook a couple of early studies, which I'll walk through right now. Well, these were all conducted overseas. We originally were a technology born out of Israel, which was taken to the US and allowed the formation of Cupron Medical Textiles. And so out of this early work that was conducted overseas, we were able to run these pilot studies to prove the concept so that we could then find a very attractive healthcare partner in the US to potentially validate this data using NHSN definitions, using more rigorous, potentially infection control practices. And that's really where Jackie and her team come into play. But this pilot data was important really as a proof of concept. So this was one of our earliest studies. It was a study, as I say, conducted in Israel. It was a 6-month pre and post study that was conducted. We used literature-based definitions of infection because Israel as a country doesn't have a standardized infection system like NHSN. So we were able to apply some rigor by putting in literature definitions. And ultimately, we were able to show a statistically significant drop in HAIs. So that started out with us looking at bioburden reductions. And so we took post-use products, so both standard linens and Cupron, and we were able to compare them and say, do we see after use statistically significant drops in organisms? Because if not, we probably should go and find a new job, because if we can't show reduction of organisms, we probably are not going to be able to show outcomes based. And we were able to show that statistically significant difference between the Cupron sheets having less gram-negative and gram-positive bacteria on than standard linens. And so once we had that data point, we were able to combine that with what we were seeing in the HAA front, again using literature definitions, showing statistically significant drops in HAIs, showing reductions in antibiotic days, as well as the cost of delivering care in Israel. All of that was linked into this early study, which was a fantastic result for us. This is all peer-reviewed and published. You have summaries in your brochures. We have all the reprints at booth 715 if you want to come by and see us. So we have all of this information available. This then led us to go back and challenge that a little bit more with a more rigorous study design. So we looked at it again, another site overseas, a Herzog study, but what we did was a double-blind placebo-led study. So for those who know what that is a study where we take 2 products, we dye them so that nobody knows which one is test, which one is control, and then what we do is we cross them over so that you apply the intervention on one side and the control on the other, and then you swap them over and see if you can have the same impact so that you are able to then definitively say what it is that's doing the work. So we ran a 7-month double-blind crossover trial. Here we were looking more at physician-led antibiotic events. So we were looking at when physicians believe that patients aren't healing, they're not leaving the hospital on time, they're not looking to obviously be on that arc towards getting better, therefore needing an antibiotic. And again, we were able to see a 29% reduction, statistically significant reduction in these antibiotic treatment-initiated events, so physician-led orders for antibiotics in order to assist a patient recuperating or getting better. And so with this data set, we were able to then approach really a really great partner, a clinical partner in this process in Sentara Healthcare System with this early data, and they decided to have a look at our information and have a look at potentially validating some of this information in the US. And with that, I'm going to hand it over to Jackie to tell you all about that journey that we went on over 5 years.
Okay, thank you. Good morning, everybody, and thank you so much for being here early with us this morning. We really appreciate it. I'm going to go over some basics with you about the Sentara system itself. We have a philosophy within Sentara to always exceed on best practice, but always also look for other innovative ways to be able to reduce our healthcare-associated infections and make our facilities more safe. We use the product. I think it's really important for everybody to understand, because I do get this question a lot. We use this product, the Cupron product, as a supplement to our already advanced support for the culture of safety, as well as best practices that we've implemented within our hospital. It is a supplement that has worked extremely well for the Sentara system. A little bit about Sentara itself. We are a non-for-profit facility. Actually, we're 12 facilities, 2 trauma centers and 10 community-based facilities. 8 of our hospitals are magnet, and the other 4 are on the magnet journey. We left Joint Commission back in 2012 and went to DNV NIHO and have not looked back. It's been a real partnership with an accreditation company that we're very, very proud of. And then in 2014, 2 of our facilities, Sentara Lee and Sentara Virginia Beach General Hospital, took the leap of faith to try to be the first hospitals to be certified in managing infection risk through the DNV accreditation process. They both succeeded, and they were the first 2 hospitals in the world to become accredited as managing infection risk. So we're very, very proud of those facilities. We have a 3rd facility that's looking at going for the certification this year. We have lots of physicians, 4 medical groups. We have long-term care facilities. And our infection prevention and control department across the 12 hospitals actually consists of 21 hospital-based preventionists. Certification is an expectation. As soon as you're hired or during the hiring process, we made that perfectly clear that within 2.5 years that we expect certification of all of our IPs. Right now, 15 of them are certified. The other ones are still fairly new in our system, but they understand the expectation. So the 21 actually includes the executive medical director, who is our physician director for the whole system, corporate director, which is myself, the corporate manager. We also have a data analyst, which, you know, don't get excited out there. I know when people tell me that they have all these IPs and they have data analysts, I go, wow, I wish we had that. Our data analyst is actually shared with other departments across the system, so don't get excited that we have our very own, but she is wonderful and she can just do a great job. We also are lucky enough to have an infection preventionist that's based in our medical group. Does not work in the hospitals, works only with the physician's offices. So we're very blessed there, as well as having an independent long-term care infection preventionist. So you can see that Sentara has really supported us over the years to bring best practice and infection prevention support to our system. Now, just like everybody else, we have very well-trained staff that we annually train with the basics and best practice. We also do, in the hospitals, the DNV NIHO training, and of course, we do the DNV MIR training. I don't know if many of you know what MIR, Managing Infection Risk, is, but it is a platform specifically for infection prevention and control, and it holds those hospitals to a much higher standard of care under infection prevention and control. So we're very proud that we have the hospitals that are going and are certified in MIR. We have facility support for education across the system, not only in the mandatories, but in the just-in-time education that all of us have to do at one time or another. And our surveillance is very prospective-based. We supply the leadership with monthly dashboards that have all of the HAIs, not only for their facility, but rolled up for the system as well. We do year-to-date and monthly reports on each of the units for each of the facilities, and of course, just like everybody else, we have our monthly NHSN input and work plans. The thing that changed for us over this last year is last August, we implemented the APIC Infection Prevention and Control Program because we were doing so much manual labor that it was really impeding our ability to get out on the floor and work with the staff and work with the patients as much as we wanted to. So we did implement that in August of last year. We're still working on it to get perfection, which I'm not sure we can ever get to perfection, but it certainly has decreased a lot of our manual labor that we do within our system. So we're very happy to have that. The big thing we have going in Sentara is our communication. We have weekly reports. When I say prospective data, I really mean it's just-in-time data. The IPs follow up on all the potential HAIs, the QADIs, the CLABCs, the VAPs, the MRSA healthcare onset, and the CDI healthcare onset, daily basis, and every Monday, they have to report every HAI that they've identified from the week before. That's put in a report that goes up to leadership again so they can see right away where we are in relationship to our limit goals that we've set for ourselves every year. We also have a lot of communication through HAI news that we send out, through the newsletters at the facilities, reminders from the IPs and the educators. And this picture over here, which is, I just love this picture here. This is actually one of our nurse execs at one of our MIR hospitals. And the hospital actually went more than 14 months without having a CLABC. And she was so excited that she went out, and I think she bought all the 0 bars in the state of Virginia. And she rounded through the whole hospital all day long, talking to everybody about, thank you for working as a team to prevent CLABCs. Thank you for knowing what you need to do in your job to make our patients safer. And she had a great time all day long, just going around the hospital and giving everybody candy bars. And believe me, I stopped by and saw her a couple times because those are one of my favorite candy bars. So we get special visits by leadership at all the hospitals all the time. And then we have rounding for influence. And the rounding for influence isn't just infection prevention and control. It's EOC, it's our leadership, our physicians, our CEO has even been to some of the hospitals and walked around for rounding for influence. And they do that constantly. A lot of times we'll set up topics for them and say, look, we really want to focus on hand hygiene this month. And so they'll go out and they'll start asking at the different hospitals that they round through about hand hygiene and how are you doing it? And, you know, have you worked with the IPs on hand hygiene on your unit? So they're very, very engaged, and I think that's one of the best things about Sentara is that we do have a very engaged leadership. So what else can we do? We went round and round and round a long time trying to figure out, we are really at the end of our human interventions. We have implemented best practice. We constantly investigate to see if there's new best practice out there. We're constantly working with our healthcare providers to remind them of the expectations for patient safety. So whenever a new innovation comes out, Sentara's right there looking at it. That doesn't mean we bring in a lot of new innovations because a lot of things don't work as partners for your particular facility. But when Cupron came along, we knew that that was the innovation that we needed to supplement our infection prevention and control program. I always put this in here because this is one of my favorite cartoons. And I actually remember decades ago when I first started in infection prevention and control, I think we actually did that. You know, we had semi-private rooms and we weren't quite sure how to isolate that person, so we just drew the curtain, you know. Now we know better, but it reminds me of the good old days. Hopefully not the new days. So Cupron, it was a great partner for us. It still is a great partner for us. Cupron, the copper linens and the copper surfaces just worked so well within our facility, and you'll see in a minute on the trials. And the company themselves worked so closely with us. We had educational things that went out to the community to let them know. We didn't want patients coming in or family coming in and saying, you know, where's the white linen? Why do you have that, you know, dirty brownish kind of linen? So we really worked with the community to let them know what we were trialing at the basic hospitals we did the trials on. And then again, when we went system-wide, we did the same community education. We had tent cards in the rooms. We had flyers in the admission packets. The nurses knew how to talk to the patients, especially, you know, the older population, which I'm getting there too. When they come in, they expect to see the crisp white. They think surgically sanitary linens, so they're kind of taken back when they would come in and see the color linen. And the nurses were spot on. They were educated. They knew how to speak with the patients, so that we got a lot of compliments, a lot of interaction with the patients about what a great idea this was to protect, to wrap the patients and their rooms in protection as a supplement for safety. We did the whole gamut for the linens. We did the top sheets all the way down to the bath towels, and even our staff would come up. That's a quote from one of our staff. We want to do everything we can to prevent infections, and these copper linens and surfaces are just one piece of the infection prevention puzzle. And our staff was really engaged with the trials as well as the implementation. Our laundry services had always been a partner with us. They've been accredited laundry service, I think, for 10 years now, and they've always been a partner with us. But with this trial and then the implementation of the copper linens, we really became even closer as partners working together. They work with us whenever somebody calls the floor and the linen room and says, our patient doesn't want the copper linens. We want the white linens. So now what they're doing is they're asking questions. Well, are they saying they're allergic? Can you talk to them a little bit more about why we have the copper linens? The linen people are so engaged, and we have a partnership that we meet with them quarterly. Most of our hospitals are represented at those meetings, and then once a year, one of our IPs goes out there and does an audit of their whole process plant out there to make sure that they're meeting our guidelines and the accreditation guidelines. So the process for the Cupron linen was the same. We didn't change anything. The only thing we changed was the bags, the color of the bags for collecting the Cupron versus the white linen. So it was a very, very easy conversion. And this is a very simple little chart, which I really appreciate. I should actually say it's a very complex chart because the person's in the room that made this for me. So it's a very complex chart that shows over time, when we first started this journey in 2015, and as we progress with implementation of the linens and all the textiles and the hard surfaces, how we dropped in our healthcare associated infections, and that's per 1,000 patient days. So let's get to the study themselves. The study was a lot of fun, I have to say, and the IP from Centerally is actually here today, and I think it was a very great trial that we worked on very hard. It was the biggest trial of antimicrobial services at that time that had ever been conducted. So we had one tower that did the copper linens and the hard surfaces. We did both. They did the linens and the embedded hard surfaces. The other section of the hospital was an older part of the hospital, and it did not have the linens or the embedded hard surfaces. We did this trial over a 10-month period of time, actually had 81,000 patient days, and you can see at the bottom there, we had an 83% reduction in C. diff rates, and when we put C. diff together with the other MDROs, MRSA, BRE, the gram-negative rods, we had a reduction of 78%. Now, when we did this study, we knew that there was going to be some potential confounders, which included that we had a new building that we were working with. We had a diverse patient population across the board that we were working with. And at the same time, it was a concurrent time that we were really focusing on DNV MIR at this facility. So we had to go out and figure out how to take those confounders out of the process itself. And this is just a visualization here of where we were with C. diff and then C. diff and MDROs, and where we started with the 83% reduction, where we dropped to, and then the same thing with the C. diff and the MDROs together. And this really piqued, this trial itself and the results we got really piqued our leadership interest to the fact that they already started thinking about how can we maybe deploy this to other hospitals. So our second year study at the same facility, actually we brought in SPA, which was a brand new building to kind of negate the confounder that we found in the original trial. And then the concurrent DNV-MIR certification. Virginia Beach was going through that certification at the same time. So we really wanted to address those confounders in this study. So we have those 3 hospitals. Both of the towers at the original hospital, Lee, had the copper linens by this time and the embedded hard surfaces. It was an 11-month period trial with 79,000 patients, and we still saw a 25% reduction in C. diff rates and 28% in C. diff MDROs. And you can see here, the first one is Sentara Lee, where this is the second trial we're having, and they have complete linens and embedded surfaces. The second hospital was the SPA hospital, which was the brand new facility that had been built. And then the third hospital was the other one that had also undergone accreditation with DNV-MIR. So we took the confounders right out of it and still showed a reduction along the whole way of this trial. And by this time, by the time we got these results, the leadership had already started talking about deploying to all of the hospitals. Then in 2017, we decided to do a trial looking at the linens only, you know, the hospitals and the linens only. And what we did was we took 6 of our facilities, 6 of our Sentara facilities. It was a retrospective review. We looked at pre and post deployment of the linens. And then we looked at each of the hospitals at 90 days, 180 days, and 240 days pre and post. And you can see already, actually the one at the bottom is my favorite because it's C. diff. You know how all the IPs love C. diff, right? So you can see how much of a drop we had at 90 days, 180 days, and 240 days with the expansion of the linens, pre and post expansion. And the same thing you can see across the board for just the MDROs or the C. diff and the MDROs together. So it was a significant reduction for us that we were able to prove with the linen expansion throughout the system. And I thought I had more to talk about. I wish I did, but I don't. So here we go with, I have to give credit where credit is due. All of our infection preventionists collect data every day, every month, for us to be able to prove what a great innovative system we have going here within Sentara. So we wouldn't have been able to show you these trials or even do these trials without those and without our leadership that I have listed there. And especially without really using Sentara Lee Hospital, which is a great hospital, and they were the ones that volunteered to go through every single one of the trials that we did. So I think now it's time to hand it over to Dr. Delani. Is that it? So thank you all very much.
Okay, let me go ahead and make a little switch here. There we go. Just need to do one more thing. There we are. So I'm at another institution, which is Ochsner. Just FYI, it's located in New Orleans. And just to give you, the one slide background on our institution, we're also a non-for-profit multi-specialty health delivery system. We have about 30 hospitals and about 80 health centers that blanket across the state of Louisiana and now actually are into the neighboring state as well. We employ about 1,200 physicians. We have about another 3,000 or so that work in our hospitals. And finally, for what it's worth, we're the largest employer now in our state, so it goes to show you how big the healthcare industry has become. So My job at Ochsner is I'm a transformation officer. You're probably just saying to yourselves, what the heck is a transformation officer? But the idea is, how can we help transform the system to be able to meet the changing demands that healthcare is presenting to us? And one of the things that we look at, so we look at certainly in the outpatient arena, but we also focus on the inpatient arena, and we all recognize that hospitals themselves are pretty dangerous places. And so we actually have an innovation wing in the hospital. We're able to test new workflows and new technologies to see if we can make a difference. So just FYI, fun facts, medical errors are the third leading cause of death in the United States. It's just under 500,000 people that die. And if we look at Medicare alone, it's about a 1 in 4 chance of experiencing harm, some form of harm during a hospital admission. And then if you look about infections, HAIs, about 1 in 31 people in the United States will develop one. In the UK, it's about 1 in 10. So obviously, this contributes to the hospital harm that patients are exposed to. And then again, I'm giving you the facts that this group knows better than anybody. About almost 700,000 people each year in the U.S. will develop an HAI, of which about just over 10% of those will die from a hospital-acquired infection. And then we know that these organisms, whether they're VREs or MRSA or C. diff, can last for weeks and sometimes months in cleaned rooms. More than half of these HAIs are caused by bacteria that are resistant to at least one type of antibiotic. And then moreover, even after a clean, the areas in our hospitals get reinfected rather quickly. Most of you all know this very well. It's just a fun fun slide just to review it. But again, the major risk factors include the usual suspects, right? So it's catheters, it's recent surgeries, it's overuse of antibiotics, and finally, the most common HAIs that we know of course, are CLABSIs, C. diff infections, MRSA, surgical site infections, and UTIs. Now, it's funny because I've written a couple papers on just our efforts at our institution to reduce antibiotic use, unnecessary antibiotic use, and we've seen significant improvements along those things. But I don't think, again, we fully appreciate always the real global threat that we have today with superbugs. It was about 2 Novembers ago that we had the first American citizen that died of a routine infection actually in Las Vegas. From just completely resistant bacteria. So this is a global threat today, and prevention of HAIs leads to fewer illnesses requiring antibiotic treatment, thus reducing the development of antibiotic-resistant organisms, and of course, antibiotic stewardship is a critical factor in how we be able to manage overuse of antibiotics. Now, this is a slide that Alistair showed you a moment ago. But when we look at any hospital room, when we look at where things are most touched, and moreover, what things are most contaminated, it's the area closest to the human being that's in the room that is the area that is the most frequently contaminated. So it's the linens, the gown, the bed sheets that are the predominant sources of organisms. Just after that, it's the overbed table. But really, the linens are a major source of infection. And we know that linens can serve as a vector to spread infections to other patients within the health system. And I'll tell you, we'll get it. I'm going to show you some AI work in a moment, but the single greatest predictor of infection in our hospital, and I'm sure it's the same for all hospitals, is the amount of people walking in a door that are already colonized or become infected. So you have an infected patient or a colonized patient, again, very quickly, the gowns, the sheets become contaminated. Over time, that contamination of organisms proliferate, and then from there we can spread it all over the place, whether it goes to, into the air through bed making. And you can see the statistics there that just changing a gown or making a bed increases by 10 to 26 times more contamination in the air. And of course, the contamination in the air can settle anywhere within the room or on people that are visiting the room. Then from there, of course, you get cross-contamination to other people within the hospital. And then again, how long can contamination survive? The units on here are not minutes or days. They're actually days rather. They're not minutes or hours. And you can see whether we're talking about cotton or terry or blend or polyester or polyethylene, we're talking about many days to actually even many weeks for many organisms in terms of how long they can survive on these surfaces. So it's, you know, we have this sort of narrow window to be in. I'm trying to avoid antibiotics to kill these bacteria, and I don't want to overprescribe antibiotics for the reasons we just talked about, so I would really love to have a non-antibiotic alternative. And then now we have this element copper being introduced. And it's worth noting that not only does it have intrinsic antimicrobial activity, but it's continuous and remains effective for the product's lifetime. They kill roughly 99.9% of bacteria within hours, often within less than 2 hours of exposure. And then we'll get into the mechanism, as Alastair has already illuminated. And they're the first class of solid surface materials approved by the EPA as an antimicrobial and approved for public health use. So another mechanism slide, Alastair showed you one, I'll show you another, but pretty much they come to the same conclusion, and that is once the bacteria or other organisms, you know, get exposed to copper, it causes cell damage. Copper dissolves from the surface and causes cell damage. It leads to membrane rupture and loss of membrane potential and cytoplasmic content. It induces generation of reactive oxygen species, which further cause cell damage. And finally, genomic and plasmid DNA becomes degraded. So it is a continuous process. I love showing this slide, and this is actually, I apologize because of the quality, but it actually is very illustrative to me. This was a study done in Southampton where he took 10 million MRSA and placed them on each of two surfaces. One is stainless steel, which is on the left, and one is copper on the right, and these are that immunofluorescence. So what you see lighting up there is the MRSA. And now we're going to see what that looks like, that immunofluorescence over various time periods. So this is baseline. And here you see within 2 minutes, there's actually no difference at all. I mean, again, it's lit up, loaded with MRSA. Within 6 minutes, it's not a close-up, but what I can tell you is there's a little bit of lighting up on the right in the copper, but obviously the stainless steel is unchanged, and here you are at 9 minutes. I mean, it's completely devoid of MRSA. This is looking at E. coli now, much the same type of experiment now, and this is about roughly 100 million on the surface of both stainless steel in blue and polyethylene in red. And you can see time course going out for several hours, and then within literally less than 2 hours, you're seeing a complete elimination of E. coli once exposed. So we've talked about the efficacy across a variety of organisms. It's worth making a point that it's already shown some efficacy in terms of influenza A, adenovirus, and various fungi. And on the right-hand side is actually the submission to the Environmental Protection Agency showing the efficacy in terms of killing a variety of organisms in multiple experiments. And the point is, in almost every one of these, it's greater than 99.9% kill. So this led the EPA to be able to approve copper as an element that actually has bactericidal effects. So now we can say, well, you know, let's talk about the story of within healthcare. This was an early study at Selly Oak Hospital. It was merely it was a crossover trial, and they looked at just surfaces in the same ward. And they had overbed tables and a variety of other surfaces, and they actually waited 6 months before they did the trial because they wanted the surfaces to be worn and cleaned and to show that it still had some effect. And the point is that the median numbers of bacteria recovered for copper surfaces were 90 to 100% lower than controls. And in fact, the only surfaces that demonstrated, MRSA or vancomycin-resistant enterococcus or E. coli were those in the control surfaces. So again, the same sort of studies that we've talked about in terms of bioburden. This was a Department of Defense trial in the ICU. These were bed rails that they looked at that in terms of contamination, and after completely cleaning them, within 6.5 hours, they were completely recontaminated, except for those that were on the copper surface bed rails that they showed almost, very little contamination. It reduced the antimicrobial burden on the surfaces, bed rails over bed tables, by about 80 to 85%, and 58% reduction in HAIs where these surfaces were in place. So again, just more data demonstrating the efficacy of copper surfaces. Now, then comes again the textile side. So now, if the worst part of the room is where the patient is, if the most contaminated area are the gowns and the linens, then what would be the impact, certainly, of utilizing textiles? And then this is what Jackie just illuminated to you in a variety of studies. And again, I'm just showing you a summary. But in the first study, she showed tremendous reductions in HAIs, but she was concerned about confounders. And then the bottom study is showing just using linens, just linen gowns and bed linens and so forth, and she's already given you the impact. But the point being is that significant reductions in MDROs and C. diff existed just by using the worst area from a contamination perspective, which are the gowns and the linens. And again, you've seen pictures of it, you have them on your table. We've done the same thing in our hospital where we took out our innovation wing and we said, okay, let's compare the impact of utilizing gowns and linens and so forth with the addition of just the overbed table on incidence, in this case, of C. diff. And so we had 2 wards. Again, we compared the C. diff infections before and after. The same story that Jackie gave you is the same story for us. It's actually these brown-colored or salmon-colored linens and so forth. It always brought up a question. Interestingly enough, I'm not joking, the patients preferred it from a softness perspective. They actually said, once they were exposed to it, they go, I like this better. In fact, if they had the choice, they would choose that. And it wasn't even just because of the anti-infective properties of it. It was just because it was so comfortable. It was like the smoothness of one of those super nice terry cloth robes that you get in a fancy hotel, perhaps. But they all really remarked positively in terms of how the material felt, and they liked that. And of course, they love the idea that now we're taking the effort to try and provide another layer of protection for our patients. So that was a really strong selling point in our program. Well, this is what it is before and after in the intervention group on the left and the control group on the right. The patient days really hadn't changed before and after, but what we saw was about a 50% reduction in the C. diff infection rate on the left-hand side, and no reduction, if anything, a slight increase in the C. diff infection rate in those that were in the control area. So we demonstrated very effectively that this was very powerful in terms of reducing C. diff. And then we went and decided to take a step further. So we've done a lot of work in our hospital using AI to predict things. We actually, and I won't spend time talking to you about this, but we can actually predict codes 4 hours before a code pretty effectively. And so we've done some work in terms of having teams that meet the patient 4 hours before and do all kinds of things which has nothing to do with infections. So we said, we've had some success there. Do you think we could look at AI to see if we could predict C. diff in people that don't have C. diff today? So they enter our hospitals, they end up getting C. diff. Oh my God, is there a way that we could have known the day they arrive that this is a person that has a very high likelihood of actually getting it while they're here? So here's how we did it. We actually ran a model. We looked at over 250,000 admissions over a period of 3 years for anybody that developed C. diff. And we ended up with a very powerful model, as I'll show you. What's also interesting about it is we discovered things that has not been heretofore reported in the literature. So if you look in the literature, you say, what's the greatest risk factors for developing C. diff in a hospital? It would be antibiotic use, and not only not antibiotic use, but even specific antibiotics. And what we found was that certainly antibiotic use was very powerful, and was really just about any antibiotic. But the leading risk factor was actually, outside of the pressure in the system, was actually acid suppression. And if you look in the literature, it's always going to be a PPI that's blamed, but we found that even H2 antagonists have the exact same impact as PPIs do. In fact, even high doses of antacids do. So any form of acid suppression was a strong predictor of C. diff infection. And so we were able to intervene in this study that I'm showing you with a small group of pharmacists. So we didn't have to train 1,000 nurses in many of the interventions we do. We have to train the entire staff as to how to make a change. We were able to do this with pharmacists calling the physicians and saying, can we make an adjustment in either antibiotic or acid suppression or what have you, and so forth. So here's the model. So just think, if you're not used to looking at these kind of prediction models using AI, let me get you oriented. This is what's called a C statistic. This is the AUC. So the dotted line that's right across that box, that's a model that would have a 0.5 prediction of risk. What that means is it's no better than a coin flip. So if I were to tell you, last night there was the Stanley Cup playoffs and there was 2 teams, and I'd say, oh, I know who's going to win. Bingo. I don't know anything. So my point is, my ability to predict is no better than a coin flip. And so if you get a little above 0.5, then it's a little better than a coin flip. But so just so you know, so this is the typical way we look at models. A value of 0.5 means the model is no better than a random chance. Of 0.7 is a pretty good model. 0.8 is a really strong model. So if I had a model that had a 0.8 AUC, then that's pretty good in terms of predicting who's going to win the Stanley Cup or who's going to get whatever that you're trying to predict. So we had a model that was 0.89. It was extraordinarily powerful in being able to identify people. Remember, these are people that don't have C. diff right now, but identify people who were the most likely people that, if you just sit back and wait a few days and don't do anything, she's getting it or he's getting it. And so then the intervention was, okay, well, now that we got a model that reliably predicted it, not for 100% of the people, but for the majority of people, what could we do? And so this was the intervention. And the intervention really focused, again, back on Cupron. It was back on the linens. And then for many of these patients, we didn't actually have them for all of them, overbed tables that had copper impregnated. But the real big impact was the linen. And then we also had the pharmacist call the attending and say, can we kill that PPI? Or can we kill that H2 antagonist? Or, you're on this broad spectrum antibiotic, do you really need it? Or could we create a narrow spectrum antibiotic? Obviously, like any good, program, we're going to use the routine stuff like soap and water. And so because this was a high risk for C. diff, we recommended soap and water. And this is what the results were. So this is now looking at 17 consecutive months in one hospital, which is our biggest hospital. And this was the amount of C. diff infections that were recorded per month in a pretty large sample over 17 consecutive months. And now we've taken this out. We started this literally 11 months ago. So what I'm showing you, actually, we haven't published this yet, so don't tell anybody. But here's the results. And so what we're seeing now is about a 38% reduction in our C. diff rates very consistently. In fact, I get a report every single morning that shows where we are today, month to day for that month. And it's been a very consistent reduction in our C. diffs. So this is a slide that Alistar showed. Again, why copper? Again, I think that the key part of this is that it's continuous. It's not a one and done. It's not a terminal clean and now it just gets reinfected. It's a continuous process. And that's really, I think, part of the secret in addition to avoiding use of an antibiotic. So I just summarized by saying, look, we've got a problem from an HAI perspective. Obviously, I'm telling the group that knows this better than anybody. We obviously want to continue to reduce antibiotic use when possible. But these products have a unique mechanism that avoid the use of antibiotics and have a continuous function over the lifetime of the product and are very complementary to all the good things that we're already doing to try and prevent infections in our hospitals. Thank you.
So this is where I'm hoping I don't break the rest of the presentation because we don't have much left. But I think in summary, we obviously have heard today 2 great examples of outcome-based data resulting around the Cupron Medical Textiles. So on the operational side, just to give you a little bit more groundwork on how we processed and what does that mean? Well, we process daily in a large number of laundries. We work with a very high number of laundry partners around the US. We've been used for over 2 million patient days now in the Sentara healthcare system. We've had no adverse or safety events linked to the copper. There's really no changes in processes or staff practices, as we've heard, apart from the one color bag, and that's purely just to expedite your laundry's efficiencies. And we're very confident that we've been clinically validated in both settings, thanks to Sentara and Ochsner, to be able to help you in the fight against HAIs, especially in C. diffs. ROI is always going to be a big point that gets raised, and a very valid point too. You know, we're all operating on budgets that are unfortunately not growing, probably shrinking, and you've got to do more with them. But to that point, I think it's important for us to raise that in addition to the color, which is obviously a great differentiator when combined with the educational practices at Sentara and the information at Ochsner, you know, it's great to hear that patients love it. That's always great for us to hear. But that color also leads to a durability where the number of servings is how many times can a product be washed and returned into use. Our products, because they're slightly higher quality probably than some of the products that your laundries are offering, and because of that unique color, which means that, you know, aesthetic stains which might lead to white products being removed from service do not appear on our products, we can actually have about 80% more servings. What does that mean? Well, over the lifespan of the linen, you need to buy less replacements than you would do for the white product. So just another factor to put into this ROO mix, you know, in addition to being able to really assist with your fight against HAIs and whatever financial servings are in there is also a durability and a longer term play. And I think finally, you know, we've heard this all morning, but just to recap and round out for the day, you know, we have a continuously active intervention that is complementary to everything that you're doing. We're easy to implement. We've been used for a very large number of patient days in a number of healthcare systems. Fortunately, we've had both of our speakers here today to tell you about their experiences. That unique color is fantastic for leading when combined with good educational efforts to really positive patient interactions and patients becoming more proactive about it. The linens last longer. They have better durability, as I said in my last slide, which can obviously assist with the ROI. The antimicrobial in them can last all throughout the life of the product, so it's efficacious for that long. And we have a number of peer-reviewed and published studies of the studies. And the point I'd make about that is we have all of those reprints available in our booth. We're in booth 715. If you'd like to pop by and see us later today, happy to provide you with all of those reprints. And I think at this time, I'm just going to close it out and say we have one microphone. So I'm going to ask one of my colleagues to bring it into the middle. So if you would please join me in saying thank you to Dr. Milani and Jackie for the presentation this morning. We probably have about 5 to 10 minutes to take some questions before we get you out into the rest of your day.
It's on right now.
Any questions?
Thank you very much for the presentations. I just want to know whether or not skin irritation at all has ever been documented, because we indirectly have heard about different things with different formulations and different chemicals being impregnated into the linen. So I just wonder if you have any feedback on that.
Yeah, Jackie probably can add to whatever I tell you, but you know, in all of the studies, the trials that we've run, I think we had 9 supposed skin irritations that were dermatologically independently analyzed, and it wasn't linked to the copper, it was linked to some other chemical during the care. So we've been used for over 2 million patient days now with no skin irritations. I think there's only 2 prior pre-existing conditions that we, out of an abundance of caution, would say are contraindicated for our technology, and that's Wilson's disease and Menkes disease. They're both genetic conditions that are linked to not being able to control copper levels. But no, we haven't seen any skin allergies. We've been used widely in the consumer industry and the cosmetic industry too, with no feedback or no complaints there. But it's a very valid question, but no, we're safe and efficacious for use.
The science of this is, clear. However, the operative issues that often infection prevention gets involved in when there's something innovative introduced. Working with your linen partner, your laundry partner, I live in a city where multiple healthcare systems, different ones, use the same laundry contract. And separating out by colored bag, those kinds of things could probably be achieved. But is there a point where you say that this textile half-lives, that you would want it to be exchanged for new? Because the ability to mark that, it just doesn't exist, and it's not to say it couldn't, but, you're saying you tested out to 100 washings. Is there anything that's been looked at for, when would you, clearly if it's deteriorated, it's damaged, but it just in terms of, it's not efficacy, so do you just never half-life it?
Yeah, so I think if I think what you're asking, just to make certain I understand your question, is there a point at which we would recommend that you take our linens out of service and buy new, as opposed to, and the answer to that is no, we don't have a recommendation, just because of the way that you standardly use linens is the same way that you would use our linens. So eventually they will become cut, somebody will put leads on them or tape on them, or they'll disappear into a red bag instead of our bag. So you are naturally going to have a turnover process where new linens will be injected, just as that lifespan, that half-life, if you will, from when you buy a product to when you're going to need replacements would be longer with our products than it traditionally would be with the white products, but we still have a natural ebb and flow of product coming in the door and being lost or removed from service. So we don't have a recommended X number of washings and needs to go out, no.
And I can tell you from our perspective that our linen service, who is our partner, is actually very good at checking the linen that we send back to them, as well as any of the ESD people or the nursing staff. If they feel that it doesn't meet our standard, then it goes into a separate bag to be disposed of. And we do reorder the copper linens we have, because we've had them for so many years, but there is a process to make sure that we don't put something that's not acceptable to us on the patient's bed.
Thank you. Great presentation. Have any of your trials included burn patients or pediatric patients or neonatal patients?
Great question. The short answer is no, we haven't looked at that population. We've really focused on, and I think from Dr. Milani and from Jackie's point of view, we really focused on adult inpatient areas where the infection rates and what we sort of set out to do is probably more predominant. There are areas like that. There's probably some other areas that people can think of that would be nice to add to now, but the journey we've been on has really been trying to fundamentally differentiate ourselves from other offerings in the marketplace by not just stopping at bioburden, but actually going down that pathway to produce peer-reviewed publications that show good outcome measures. So the answer, I guess, would be not yet, but we'd be delighted to talk to people about potentially looking at those areas.
It's actually a good idea.
Good morning.
Good morning.
What is the difference in using copper than silver? I know for years people have promoted silver in fabric.
Yeah, it's a great question. So, the silver offerings that were out there were a plated fiber, and I think there were some serious concerns about discoloration issues, and then there were also some issues around potentially having patient harm because it was conductive. I don't think that's on the marketplace anymore. And then I think compared to other silver offerings that are now being, I think, launched around us, the big difference really is how broad spectrum we are compared to silver. So you could probably say, we're, no pun intended, but we're a wash on the bacterial efficacy, but on the sort of fungal efficacy and the sporicidal efficacy, I think copper has an edge, and is known more as a more widely used, I should say, as a broad spectrum fungicidal and sporicidal agent, which I think has better applicability in this setting. I think the other point I'd make about it is I am not aware, and maybe this room can help me with the collective knowledge, but I'm not aware of any silver studies that actually show outcomes or any reduction in HAIs when they're being deployed. I'm familiar with some bioburden studies, but I have not seen anything that actually shows clinically that they have any value beyond that bioburden reduction. So that would be the two main points I'd make is we have now, thanks to our partners, we have a growing body of evidence that shows that we can assist you in reducing your HAI rates, and also that we have probably more broad spectrum. I think the final point I'd make too is longevity. So the only silver offerings I'm aware of now, they come into the marketplace and they're treated, but what product's treated, you can't see it, you don't know how much is on there, and you don't even know if it's been applied. That's always been a concern, whereas obviously we have my marketing department would probably tell me that this is rose gold, but we have copper-colored sheets that give you a visible indicator that the antimicrobial is there for the life of the product. So those would probably be the three main answers, I'd say. Oh, welcome. Does anybody have anything else for myself or the panel? I feel like I'm hogging all of the questions. Does anybody does anybody have anything else for the group? Okay, I'm going to say thank you so much for your time this morning. There is some more food at the back. Help yourself, and thank you. Have a great day.